Hello, this is presentation 5, Standard Normal Distribution and Box-Mueller Method. I'm Shin and I'm in the same team with Francisco and Alana. The standard normal distribution is when normal random variables has a mean of 0 and a standard deviation of 1. This means that when generating random variables, the results will form a bell-shaped curve and result in a standard normal distribution. The standard distribution function is 1 over the square root of 2 pi times e raised to the negative value squared divided by 2. Standard normal distributions are used in statistics on data temperature and test scores and similar data type.
Here we'll be talking about the Box-Mueller method. And as you can see with the first bullet, there's an equation. The Box-Mueller method feeds from the standard normal, but the difference is that it has two independent standard normal variables. So for it to be transformed into polar coordinates, you have x1 and 2, because again, we need two variables. And for x1, we have r cosine theta, where r would be a positive number and theta is going from 0 to 2 pi. And for x2, it's similar. The difference is that it's using sine, so r sine theta. And then for it to be transformed into Cartesian coordinates, we again have two variables, x1 and 2, and x equals square root of negative 2 natural log r1. So that's your first random variable, and then you have that times cosine 2 pi of r2, and that's your second random variable. And again, the only difference between x1 and 2 is the sine cosine.
As we discuss the Box-Mueller method, there also is a MATLAB code that shows both polar points on a graph and Cartesian points on the graph. So on the left side, as you can see, it has a loop from I equals 1 to 1,000, and then it has theta equaling a random number times 2 times pi, and then it has xi and y of I, and that is each equaling, well, xi being random times the cosine of theta, and then random number times sine of theta. And then for the Cartesian points, it's the same, but the only difference is that instead of it being random times cosine and random times sine of theta, you do an inversion, which equals the square root of negative 2 times log of the random number, which does the inversion, so the polar coordinates turn into Cartesian points, and then you graph that. Here on this next slide, you can see that the Cartesian coordinates are plotted on the left side and the polar coordinates are plotted on the right. So on the left, you see more of a x and y plot, and then on the right side, it's more of a circular plotting for the polar coordinates.